Okay, this is a rant about quality. Okay, there is this movement in industry about quality, or there was in the late 90s. I don't know, or in the mid to late 90s, I don't know how much that's still going on, but there's the 9000, ISO 9000, ISO 9001, the quality thing. And it's like, oh yeah, we're a Six Sigma organization. And actually, I never figured out exactly what Six Sigma means, which is kind of embarrassing. But I know that a sigma is one standard deviation, and Six Sigmas is six standard deviations from the mean, which means that's like very, very rare events. And so I'm assuming it means something like we have a very, very small probability of getting a defect, or something like one in 100 in 10 million parts or something are defective, right? So quality in manufacturing is about having a low number of defects. Okay, it makes sense in manufacturing. It's like, what can we do to improve this process so that it generates high quality, consistent high quality product results, right? And that makes sense for manufacturing. The thing is that then there's this thing of like, oh yeah, we want quality everywhere. I don't know if you've read the book Zen and the Art of Motorcycle Maintenance. I finally read it and I really loved that book. And so in that book he talks about what quality is. It's all about what quality is, and it's written from a perspective of this guy traveling across the country with his son on a motorcycle. And it's like, I'm getting goosebumps now, because it's like he embodies quality, and the book embodies quality, and the whole experience embodies quality. And it's like he's talking about quality, and it's a fucking beautiful book. And the end of it, it's just beautiful the way it ends, and it made me cry. Made me and my wife cry, actually, listening to the Audible version of it. And I've had a lot of experience with quality. Like, for example, I used to design graphics processing units, GPUs, and I used to design parts of these chips, and these chips have billions of transistors in them. Is it billions or hundreds of millions? I don't know, it's billions, I think. And like, so I design a circuit, right? I mean, which is like just like tens or hundreds of millions of transistors, and all these transistors, they have to interact and do the right thing, right? And if one of the connections or one of the transistors is wrong, then the thing won't work. It doesn't work right in some weird corner case, and then the chip doesn't work, right? And if the chip doesn't work, you have like this manufacturing line somewhere in Southeast Asia, with like, in our case in Taiwan, with like the size of multiple football stadiums, with you know, full of these machines, each machine like $1 million to $10 million, like just lines and lines of machines. And these wafers, these big silicon wafers, which cost, I don't know, tens of thousands for each wafer. And there's rows and rows and rows of them moving through this production line. And like, you know, at some point they're going through this production line, it takes weeks, right? And at some point you realize, oh fuck, there's a bug, there's one single bug, there's one single issue, and it's a deal breaker, and you cannot continue. You have to stop, right? You have to stop the production, and all of those wafers and all of that time and all of that fabrication factory time and expense is wasted. So you waste hundreds of millions of dollars because you had one tiny little mistake. So I had to make sure that the thing that I was designing, the piece of the chip that I was designing, had zero defects in it, in the design, right? And so how you do that is you do lots of simulations, you create lots of test cases, and you run simulations, and you model what the output should look like, and you check the two, and you create like weeks worth of simulations that just run on server farms, massive rooms full of just racks of computers just running and running and running as quick as they can to test all these cases, to simulate all these cases. And then you have these emulators, which I don't know if they still use emulators like this, but they were just like a box, like a TARDIS box, which is filled with field programmable gate arrays, which is reprogrammable chips. And these chips are all configured to try to function like an actual chip. So you've got this massive box, it's like this big, and basically this box functions like a tiny little chip like this, but it operates like 10 times slower or 50 times slower. And then so you run all the tests on that, and that's a lot faster than running them on simulators. Anyway, so I was pretty good at that, right? I mean, I could build something with tens or hundreds of millions of transistors and have 0 bugs, right? My stuff would come back with 0 bugs. And the reason it would come back with 0 bugs, the reason there were no bugs, oh, by the way, one day my boss goes to me, he goes, because I didn't used to work on weekends, right? And my boss goes, Duncan, when this chip comes back, you're gonna have to come into the lab on the weekends. And I was like, and internally I was like, fuck no, I'm not coming into the lab. And I just go, okay, the chip comes back, no bugs. No bugs in my stuff, right? No issues with my stuff. It just fucking works. The software just runs on it. And so I didn't go into the lab on a weekend, right? The reason I didn't go into the lab on the weekend is because I was producing quality work, right? So I don't do something and then do it again and then do it again and then do it again. It's all about doing it once, right? So I would do it once and it'd be done. It's like in manufacturing. The parts come off the production line, they're just good. You're done. If there's a defect, you go back, you find out where it was happening, you stop the production line, right? In Kaizen, Japanese manufacturing, you stop the whole production line. Everyone rushes over and figures out what's broken on the production line, and then you start again. Because you don't want to have any shit coming off the end of the production line. In fact, this is why German car manufacturers were beaten by Japanese, because the Germans would get all these cars off the production line with fault. They'd have a whole QA team looking at these cars and they're like, oh yeah, there's a dent there. Oh yeah, that thing doesn't fit properly. Oh yeah, that thing's not working. And they would fix them all and they'd be fixing all these cars. Whereas the Japanese production lines the Toyota production lines would just produce good quality stuff and it would not have to be reworked, right? And so they could produce more cars for less cost. And they beat the American manufacturers and the German manufacturers. Okay. So how do you produce high quality stuff? Whether it's on a production line or whether it's more difficult, which is design. Okay, so in design, in knowledge work, or in what I'm doing here in this video, right? How do you produce good quality stuff? And the way that you produce good quality stuff is the same thing as on that production line, in fact. You don't like do the ISO 9000, ISO 9001 thing, which they did actually at a previous company I worked at, where they came in and said, oh, you have to write documentation for everything. You've got to, so it's like, oh, we're going to formalize the process of getting quality. No, you don't do that. You don't formalize some weird fucking process of getting quality. You don't go, how does this person over here get quality? No, the actual way they get quality, is they actually pay attention. Okay, you pay attention, you learn to pay attention, you learn to focus, pay attention, and actually be present. And at each moment, think about, oh, how could this go wrong? Oh, who's going to come back and look at this design in 3 years' time and not understand it? And do I need to write some documentation for this piece? Not do I write documentation for everything, but for this piece. Oh, this thing here, what are the corner cases which I have to simulate which might be broken? To check that it's not broken. Right, so, and how can I thoroughly test it? Oh, I'm going to test this little piece and then this little piece and then plug them together and test all of this. And then I'm going to plug it all together and test all of this. And applying conscious focus and awareness at each stage is what produces something quality at the end, which is like on a production line where applying a high quality process all the way through produces a quality result. And if there's something wrong with that process, you go and you fix the process, right? Specific to that part, specific to making that thing, right? It's not a standardized thing. You can't legislate it. You can't produce rules and laws for it. There's a simple rule and there's a simple law, which is simply apply focused care and attention at each stage, which kind of makes sense, right? That's what you understand quality to be. You see something and you go, oh, that's a high quality thing. It's like you kind of know that's because a lot of care and attention went into doing that. Right? If you get a really good meal and it's like, wow, look at that, it looks beautiful, it smells beautiful, it tastes beautiful, it's well presented, it's well delivered, it's fucking awesome, right? And it's like, the reason it's like that is because someone put a lot of care and attention into it. So learn to practice and develop your care and attention, learn to apply your care and attention, and you will produce quality and your company will produce quality. Teach your employees how to be more present and more focused, and they will produce quality. Okay, don't legislate it and control it into them. Support the thing that essentially is quality, which is a care, attention, and focus.